When the United States entered World War II, it did not do so as a fully prepared military power. In December 1941, the U.S. Army was still smaller than several European forces, its air fleet outdated, and its industrial output geared towards civilian consumption rather than mass warfare. Yet within 3 years, American factories would produce aircraft at a pace no nation had ever achieved before. By 1944, the United States was building a heavy bomber roughly every 63 minutes. This was not a slogan or a rounded estimate. It was a measurable production rate sustained over months. The scale of this transformation reshaped the war far beyond any single battlefield. Victory would not be decided only by generals or soldiers, but by assembly lines, logistics schedules, and workers who never saw combat yet determined its outcome. This industrial acceleration did not happen spontaneously. It was the result of deliberate decisions made early in the war, based on a sober assessment of what modern conflict required. American planners understood that air power would be central to defeating Germany and Japan. Strategic bombing demanded not dozens or hundreds of aircraft, but tens of thousands, backed by a replacement pipeline capable of absorbing staggering losses. Aircraft were not expected to last the war. They were expected to be consumed by it. This assumption drove production goals that seemed absurd at the time. Pre-war factories were incapable of meeting such demand. New ones would have to be built from scratch, retooled at unprecedented speed, and staffed by a workforce that often had no prior experience in heavy manufacturing. The challenge was not simply technical, it was organizational on a national scale. The United States responded by treating aircraft production as a system rather than a series of individual factories. Designs were standardized to reduce variation. Components were broken down into modular parts that could be produced simultaneously across multiple locations. Supply chains were reorganized so that delays in one area did not halt entire assembly lines. This approach borrowed heavily from automotive mass production, but adapted it to machines vastly more complex than cars. A single heavy bomber contained hundreds of thousands of parts. Every rivet, cable, engine, and instrument had to arrive in sequence. If one failed to show up, the line stopped. Keeping it moving required coordination across thousands of suppliers spread across the country. One of the most ambitious examples of this effort was the massive bomber plant built in Michigan, designed specifically to produce heavy aircraft at a rate previously considered impossible. The goal was not incremental improvement, it was industrial shock. Engineers redesigned workflows repeatedly as production ramped up, eliminating bottlenecks through trial, error, and relentless pressure. Early output was slow and chaotic. Mistakes were frequent. Aircraft rolled off the line incomplete or flawed. But instead of slowing production to perfect quality, the system prioritized volume while fixing problems in parallel. The logic was ruthless but effective. It was better to build many imperfect aircraft and improve them quickly than to build too few perfect ones. The war did not reward caution. Labor shortages posed another obstacle. Millions of men were serving overseas, leaving factories understaffed. The solution reshaped American society. Women entered industrial workforces in unprecedented numbers, trained rapidly to perform tasks once considered specialized. Shift work became constant. Factories ran day and night, 7 days a week. The concept of a work day lost meaning. Production schedules dictated life. Entire communities reorganized around factory clocks. The goal was singular: keep the line moving. By the time American bomber production reached its peak, the output stunned allies and enemies alike. Aircraft losses that would have crippled other nations were absorbed without slowing operations. Bombing campaigns could be sustained at a scale that overwhelmed German defenses not through tactical brilliance alone, but through replacement capacity. The fact that a bomber could be built every 63 minutes was not merely impressive, it was decisive. It meant that air power was no longer constrained by scarcity. It could be applied relentlessly, regardless of cost. This reality forced a strategic shift. The question was no longer whether bombing campaigns could continue, but how long the enemy could endure them. The United States had transformed time itself into a weapon. And that transformation began not in the skies over Europe, but on factory floors thousands of miles away. Reaching a production rate of one heavy bomber every 63 minutes required abandoning nearly every assumption about how complex machines were supposed to be built. Before the war, aircraft production was closer to craftsmanship than mass manufacturing. Planes were assembled in small batches, with skilled workers fitting parts by hand and correcting imperfections as they went. This approach could not scale to wartime demand. American planners realized that if bombers were treated like bespoke machines, production would collapse under its own weight. The solution was radical standardization. Aircraft designs were frozen early, even when flaws were known, because constant redesign slowed output. Instead of perfecting the aircraft first, engineers committed to improving it while it was already being produced in large numbers. This decision ran counter to peacetime engineering culture, but it was essential. In war, consistency mattered more than elegance. A design that could be built quickly and repaired easily was more valuable than one that was technically superior but slow to produce. The most visible symbol of this philosophy was the creation of enormous, purpose-built factories designed around flow rather than craft. The largest of these, operated by Ford Motor Company, applied automotive assembly line principles to aircraft construction on a scale never attempted before. Bombers were no longer built in one place from start to finish. Instead, the aircraft was divided into major sections: nose, fuselage, wings, tail, each produced in parallel and then brought together late in the process. Thousands of subcontractors supplied standardized components that arrived according to tightly controlled schedules. If one supplier fell behind, others were rerouted to prevent stoppages. Engineers monitored production data daily, identifying bottlenecks and redesigning workflows on the fly. The factory itself became a living system, constantly adjusted to shave minutes off each step. Early production runs were slow and error-prone, but speed increased exponentially as the system stabilized. This relentless focus on throughput reshaped labor practices as well. Most workers had never built aircraft before. Many had never worked in heavy industry at all. Training programs were designed to be fast and narrow, teaching specific tasks rather than broad skills. A worker might spend an entire shift installing the same set of rivets or wiring the same panel. Mastery was measured in repetition, not versatility. This specialization allowed inexperienced labor to reach high efficiency quickly. Quality control was shifted downstream. Instead of stopping the line for every defect, inspections identified problems that were corrected later or addressed in subsequent production runs. The goal was to keep aircraft moving forward even if they were not perfect. Wartime logic accepted rework as a cost of speed. Material flow posed another challenge. A single heavy bomber required hundreds of thousands of individual parts, from engines and propellers down to the smallest fasteners. Coordinating their arrival required unprecedented logistical planning. Railroads, trucking networks, and ports were integrated into production schedules as tightly as the factory floor itself. Delays were tracked in hours, not days. Inventory buffers were kept intentionally small to prevent congestion and inefficiency. This made the system fragile but fast. When it worked, output soared. When it failed, the entire line could stall. To manage this risk, planners duplicated suppliers and built redundancy wherever possible. The goal was not resilience in the long term, but momentum in the short term. As long as production continued faster than losses, the system was succeeding. The emphasis on speed also influenced how problems were solved. Engineers no longer waited for perfect solutions. Temporary fixes were implemented immediately, with refinements added later. If a tool slowed production, it was replaced, even if the replacement was inferior by peacetime standards. If a process worked well enough, it was kept. This mindset clashed with traditional engineering discipline, but it aligned with the realities of total war. Aircraft were expected to fly a limited number of missions before being damaged or destroyed. Longevity was secondary to availability. What mattered was that bombers were ready now, not flawless later. By 1944, these methods converged into something unprecedented. Production lines ran continuously. Finished aircraft rolled out at intervals measured in minutes. Losses over Europe were replaced almost as fast as they occurred. The statistic, one bomber every 63 minutes, was not a public relations exaggeration. It was the outcome of a system optimized ruthlessly for speed. This industrial tempo did more than supply aircraft. It altered strategic calculations on both sides of the conflict. For the first time, air power was limited not by production capacity, but by the enemy's ability to endure it. By 1943, the scale of Allied bombing over Europe had reached levels that would have been unsustainable for any other nation. American bomber formations flew deep into hostile airspace, absorbing losses that, on paper, looked catastrophic. Entire crews failed to return. Aircraft were destroyed by flak, fighters, weather, and mechanical failure. In some periods, loss rates exceeded 10% per mission. For most air forces, such attrition would have forced an immediate reduction in operations. For the United States, it became an accepted cost. This was only possible because production no longer lagged behind destruction. Aircraft lost in combat were replaced almost as quickly as they were written off. The industrial system was now operating at a tempo that fundamentally changed the logic of air warfare. The limiting factor was no longer how many bombers America could build, but how many crews it could train and how much punishment the enemy could endure. This imbalance placed German defenses under relentless strain. Fighter units achieved local successes, shooting down bombers at alarming rates, but those victories failed to alter the broader trajectory. Every aircraft destroyed was offset by new ones arriving in England in continuous waves. Airfields expanded. Maintenance units worked around the clock. Bomb groups rotated aircraft without interrupting operations. The psychological effect on German pilots and air defense crews was profound. Tactical success no longer translated into strategic relief. Destroying bombers did not reduce pressure, it merely consumed resources faster. American planners understood this dynamic clearly. The goal was not to avoid losses entirely, but to impose a tempo the enemy could not match. Industrial output became a weapon of attrition, applied not to ground forces, but to morale, infrastructure, and defensive capacity. This production advantage also allowed the United States to absorb mistakes without catastrophic consequences. Early bombing raids suffered from navigational errors, ineffective formations, and inadequate fighter escort. Losses were severe, but instead of forcing a pause to rebuild strength, operations continued while tactics improved in parallel. Long-range escorts were introduced, formation flying evolved, targeting accuracy increased incrementally. None of this required halting production or slowing the campaign. The industrial base provided a cushion that insulated strategic experimentation from immediate failure. Other air forces had to choose between learning and surviving. The United States could do both simultaneously. The sheer volume of aircraft also changed how commanders thought about deployment. Bombers were no longer treated as scarce assets to be preserved at all costs. They were tools to be used aggressively. Maintenance standards remained high, but the expectation of loss was built into planning. This mindset contrasted sharply with pre-war assumptions, where aircraft were expensive investments meant to last. Wartime reality inverted that logic. A bomber that survived too long without flying missions was wasted potential. The purpose of production was not accumulation, but consumption. Aircraft existed to be used, damaged, and replaced. The faster that cycle turned, the more pressure was applied to the enemy. Behind this relentless tempo stood an industrial workforce operating under constant strain. Factories continued to push output despite material shortages, labor turnover, and technical challenges. Improvements were incremental and cumulative. A few minutes saved on one station multiplied across hundreds of aircraft. A minor redesign in wiring or panel installation could shave hours from final assembly. Over time, these marginal gains compounded into extraordinary results. The production rate that once seemed impossible became routine. The statistic of one bomber every 63 minutes was not a peak anomaly. It was sustained output achieved through relentless optimization. By the time Allied air power reached its full strength, the strategic consequences were unavoidable. German industry faced continuous attack. Transportation networks were degraded faster than they could be repaired. Air defenses were forced to respond everywhere, all the time. Even when individual raids failed to achieve their objectives, the cumulative effect was devastating. The enemy could not rest, regroup, or recover at the pace required. The United States had achieved something unprecedented. It had transformed industrial capacity into continuous strategic pressure. The battlefield extended from factory floors in America to skies over Europe, linked by a production system that made time itself an advantage. By 1944, the implications of America's bomber production rate were no longer theoretical. They had reshaped Allied strategy at the highest level. The United States no longer planned air operations around scarcity or conservation. Instead, air power was applied as a continuous, grinding force designed to overwhelm the enemy's capacity to respond. The leadership of the United States Army Air Forces understood that the decisive advantage was not any single aircraft or mission, but the ability to sustain pressure indefinitely. German planners could anticipate individual raids. They could mass fighters over key targets. They could improve flak belts and harden factories. What they could not do was escape the rhythm of attack imposed by American production. Bombers destroyed in the morning were replaced by new arrivals weeks later, while German losses, aircraft, pilots, fuel, and infrastructure, accumulated without meaningful recovery time. The war in the air became a contest of endurance, and the United States had engineered itself to win that contest by default. This industrial advantage also narrowed Germany's strategic options. Defending against massed bomber formations required diverting enormous resources. Fighter aircraft pulled from other fronts, pilots rushed through shortened training programs, fuel stockpiles consumed at unsustainable rates. Each decision created new vulnerabilities elsewhere. The Luftwaffe's effort to counter American bombers weakened its ability to support ground forces. Rail networks damaged by bombing struggled to move coal, steel, and troops efficiently. Even when factories remained standing, production slowed due to power outages, worker displacement, and supply interruptions. None of these effects depended on perfect bombing accuracy. They depended on repetition. The ability to return again and again, regardless of losses, was what broke systems rather than targets. That ability existed only because American industry had made aircraft effectively replaceable. The moral and strategic implications of this approach were profound. Air crews understood that survival was uncertain and that loss rates could be brutal. Yet they also knew that missions would continue whether individual crews returned or not. The system was impersonal by design. It valued output and pressure over preservation. This reality shaped the character of the air war, pushing it toward attrition rather than decisive blows. Critics later argued that this emphasis blurred the line between military necessity and destruction for its own sake. Supporters countered that shortening the war required overwhelming force applied without pause. Regardless of interpretation, the industrial logic was undeniable. Once the United States achieved the capacity to build a bomber every 63 minutes, it crossed a threshold. Air power ceased to be a limited instrument and became a constant condition of war. When victory finally came, the factories did not immediately slow. Aircraft continued rolling off assembly lines even as the need for them diminished. The momentum built during the war could not be stopped overnight. That momentum left a lasting imprint on American military planning. Post-war doctrine absorbed the lesson that industrial capacity was inseparable from strategic power. Future conflicts would be planned not only around tactics and weapons, but around production curves, replacement rates, and logistical depth. The bomber every 63 minutes was not merely a wartime achievement. It was a demonstration of what total mobilization could accomplish when a society committed fully to industrial war. Looking back, it is tempting to treat the statistic as a curiosity, an impressive but abstract number. In reality, It defined the character of the conflict. It meant that losses did not force retreat. It meant that failure did not require pause. It meant that the enemy's success on any given day could be rendered irrelevant by the steady arrival of replacements. The United States did not win the air war by building better bombers alone. It won by building them faster than destruction could keep up. In doing so, it altered the meaning of power in modern warfare. The war was fought in the skies over Europe, but it was decided on factory floors thousands of miles away, where time was measured not in missions flown, but in minutes per aircraft,